2017 subjective. Radio and telecommunications, 4 marks. 2. Explain the various modes of propagation briefly. Answer. The modes of propagation is classified into 3 types. Ground wave propagation, sky wave propagation, space wave propagation. Ground wave propagation, any wave having frequency less than the 2 MHz is termed as ground wave. The ground wave propagation is mainly used for local broadcasting military application. The maximum distance covered by the ground wave is less than 100 kilometers. Sky wave propagation, the sky wave is termed as short wave. It is used for long-distance communication. Any frequency, which is in the range of 5 MHz to 30 MHz, is termed a sky wave. It is used in radio astronomy, telecommunication, and TV broadcasting. Space wave propagation. Space wave propagation is defined for the radio waves that occur within the 20 kilometers of the atmosphere, i.e. troposphere, comprising of a direct and reflected wave. These waves are also known as tropospheric propagation, as they can travel from Earth's surface to the troposphere surface of the Earth. It is also known as line of sight propagation, as a signal are sent a straight line from transmitter to the receiver. 2. Or calculate the maximum effective aperture of an antenna at a wavelength of 5 m, which has directivity of 75.
The formula of maximum effective aperture of an antenna is lambda square into d upon 4 pi. Put of this given value on this formula and the answer is 149.14772.
4. Discuss the properties of D layer and E layer. Answer. D layer properties. It exists only in daytime. The thickness of the D layer is 10 km. It reflects very low frequency and low frequency. It is not used in long-distance communication. The electron density of the D layer is 400 EUC. E layer properties. It exists also in daytime. The thickness of the E layer is 25 km. It reflects very low frequency, high frequency, medium frequency. The electron density of E layer is 210 EUC. 3. Or state and explain duplexer. Answer. Duplexer is an essential component in modern gadgets using radio communication. It permits duplex communication, which allows bidirectional transmission on a single path. There are many different types of duplexer. An example of a duplexer based on frequency is wavelength filter, while a duplex based on polarization is an orthomode transducer. LN radars, a duplexer based on timing is used. 4. Briefly explain the principle of heterodyning. Answer. A heterodyne is a signal frequency that is created by combining on mixing 2 other frequency using a signal processing technique called heterodyning. 4. Or what is IF? Explain its function in receiver. Answered. In communication and electronics engineering, an intermediate frequency, IF, is a frequency to which a carrier wave is shifted as an intermediate step in transmission or reception. The intermediate frequency is created by mixing the carrier signal with the local oscillator signal in a process called heterodyning. Intermediate frequency are used in superheterodyne radio receiver, in which an incoming signal is shifted to an IF for amplification before final detection is done. 5. Define radiation resistance and phase pattern of an antenna. Answer. Radiation resistance of an antenna is defined as the equivalent resistance that would dissipate the same amount of power as is radiated by the antenna. Radiation is the term used to represent the emission or reception of wave front at the antenna, specifying its strength. In any illustration, the sketch drawn to represent the radiation of an antenna is its radiation pattern. The phase of the fields radiated from an antenna. In this method, the test antenna is used as the source antenna, and another antenna is used to receive the fields. 5. Or in case of E layer, the average electron density pound tube 10 to the power of 1 to the power of 1 per cubic meter. What is the critical frequency? Answer.
Critical frequency formula is 9 under root N max. N max is the electron density that is given in the question. So put in the formula, and the critical frequency is 2.84 megahertz.
6. The carrier frequency of an FM modulator is 1000 kHz. If the modulating frequency is 15 kHz, what are the three upper and lower sideband? Answer. The three upper sideband is.
To find three upper and lower sideband frequency, we have to multiply in sequence with modulating frequency and add and subtract with carrier frequency, and obviously add for upper sideband and subtract for lower sideband.
Said. 6. Or. Briefly enumerate the application of radar. Answer. Radar application in 5 areas. Military applications in air defense, as it is used for target detection. Air traffic control, it is to guide the aircraft to land in bad weather using precision approach radar. Remote sensing, for observing weather. Space, to guide the space vehicle. Ground traffic control, it is used by traffic police to determine speed of the vehicle.